Yeah, that's fine. Okay, this is going to be on what they call Cramer's rule. And this is for solving equations. Okay. And Cramer's rule, you're actually using, when you use Cramer's rule, you're using determinants to solve equations. We've done like 2 equations, 2 unknowns now. You've done it by graphing, where we did intersecting lines, parallel lines, coinciding lines. We did substitution, where you get one variable by itself and substitute it into the other equation. We did linear combination or elimination method. We did matrices, okay? And now this is another way to do this. And really, if I had my choice, this would be one of my faves to do this. So let's do 2 equations, 2 unknowns. So 2x plus 3y. We also did it by matrix equations. 2x plus 3y equals negative 17. And x minus y equals 4. Okay? Okay, so x equals, when you solve for x and y, they're going to be 2 determinants that are, in this case, 2 by 2s. Okay? The bottom, this determinant down here, is made up of the coefficients over here. Okay, so it's going to be 2, 3, 1, negative 1. Okay. If you're solving for x, okay, if you're solving for x, you put these in for the x coefficients. So it's going to be negative 17, 4, and then use the y coefficients. So it's going to be 3, negative 1. So you basically put the constants in where the x coefficients are. Okay, and now figure those 2 by 2s. So multiply down the diagonal to the right would be 17. Subtract the product coming back up would be 12. So that top one will be 5. Multiply down the diagonal to the right would be negative 2. Subtract coming back up, subtract 3 would be negative 5. So x would be negative 1. Okay. I like that better than substitution. I like that better than like linear combination. Okay. Now, if you're going to solve for y, the bottom one you already figured. Okay. I don't even care if you write that bottom one out. You know it's going to be negative 5. Okay. Now, for the top 2 by 2, okay. Now you go back. Let me erase some of this. Now you go back and put these coefficients in for the y's. Okay. So the x ones are going to stay the same, 2, 1, and the y's then would be negative 17, 4. You follow what I'm doing? Take those constants and put them in for the coefficients of the one you're solving for. So now multiply down the diagonal to the right would be 8, and subtract the product coming back up, subtract the negative 17, okay, and that would be 25 over negative 5, okay, and it should be negative 5. Okay, now check it. And it's an ordered, you should always write them as an ordered pair or ordered triple if you're doing 3 by 3s. So now let's check it, make sure we got our signs right. So if you sub those back in, the x and the y back in, so you'd have 2 times negative 1 would be negative 2, and then negative 3 times negative 5 would be negative 15, negative 2 and a negative 15 is negative 17, yeah, that checks. Sub in negative 1 into this one, so you'd have negative 1 minus a negative 5 is 4, yeah, that checks. Okay, so that's Cramer's rule. Okay, if you were doing 3 equations, 3 unknowns, like on your matrices problems, if you were doing those, you would have 3 by 3 over a 3 by 3. That's the only difference. And then you could do your 3 by 3 determinants by expansion of minors, by the lattice method, by the Cramer'S method, by the calculator. Okay. Okay. We're getting ready for the test. For you guys, that test will be tomorrow. The one problem test is tomorrow. Okay. And then I'm going to give you the fourth matrices problem as a practice. Okay, and I would say instead of me giving you the answer, you can check it by doing the RREF. Okay, figure out what your answer is that way. And then I'm also going to give you a practice worksheet. It's self-checking. The answers are on the back. Okay, do not just copy the answers from the back to the front. Okay, actually do the work on a separate sheet of paper. I'm looking for that in your notebook. Okay, any questions on that?